So much. Welcome to another episode of our video. So this time around, we are going to look at the question extracted from 2015. Here we go. The question reads, Figure 10.5 shows an electrical circuit containing a 12-volt power supply and a number of resistors. So we have the 12-volt power supply here. Then we have 4 resistors. The set of 3 and 6 ohms is connected in parallel, and the set of 2 ohms and 4 ohms connected in series. And we have the ammeter on the other side here. So this ammeter, which is connected here, measures the current flowing in 6 and 3 ohms resistors. Then when we find the combined resistance for these two resistors here parallel to the combined resistance of these other two resistors which are connected in series. And let's go straight to the question. Question A says calculate the combined resistance of Roman numeral 1, 2 ohm and 4 ohm. 2 ohm and 4 ohm. So when you look at these two resistors, they are in the same wire. Therefore, they are connected in series. So for us to find the total resistance for 2 ohms and 4 ohms, we simply have to add. Why? This is because they are in series connection. So we add, if we name this one as R1, this one as R2, then we have R1 plus R2. Then our total resistance will be 2 ohms plus 4 ohms, and our answer is 6 ohms. We're done. To the simplest question, of course. Then question 2 reads calculate the combined resistance of 3 ohms and 6 ohms. So there we go. So 6 ohms, 3 ohms and 6 ohms, these two resistors are connected in parallel. So we can name this one as R3 and that one as R4. So for the combined resistance, we can use this. For the resistors connected in parallel, we can use this formula here. Our R3 times R4 over R3 plus R4. Or we can apply 1 over combined resistance is equal to 1 over R3 plus 1 over R4. So this one here is only applicable, this formula here is only applicable for two resistors connected in parallel. This one here is applicable even for the resistors more than 2 connected in parallel. It is applicable. But this one also here can also be applied in finding the combined resistance for two resistors connected in parallel, even more than 2. So today let's apply this one here so that we are getting acclimatized with both the situations. So we have 1 over combined resistance is equal to 1 over 3 plus 1 over 4. So our combined resistance is equal to 1 over the value of R3, which is 3 ohms, then 1 over the value of R, we have the 4, then combined resistance is equal to the lowest common denominator is 6. 3 into 6, we get a 2, multiplied by 2, by 1, we get a 2, we're getting a 1, we're getting a 1, times that one, we have a 1. So 1 over combined resistance is equal to 2 plus 1, we get a 3 over 6. So we are going to do a cross multiplication now. So 3 times RC, it is 3 RC, 1 times 6, you get a 6. So we divide both sides by 3, and our combined resistance is equal to 2 ohms. That's it. If we apply this one, we'll still get back to the same here. We go now to question B, which reads, calculate the reading of the ammeter in the circuit diagram above. So this ammeter here is measuring the current flowing in these two resistors there. So using Ohm's law relationship where R is equal to V over I, we want to find the current. So we have to make I as the subject of the formula. So by now, we know how to make one quantity as a subject of the formula. So R times I, you get Ri. 1 times V, you get V. So you divide both sides by R, and current is equal to V over R. So what is our voltage? For the voltage following in parallel connection, for the resistors connected in parallel, they receive the same amount of voltage here. So we are going to write 12 over